Ordinal regression is an important type of supervised machine learning task which has properties of both classification and regression tasks. Unfortunately, most data scientists make a mistake and consider an ordinal regression task as a multi-class classification task. The reason is that, like a multi-class classification task, the learning task of ordinal regression is to assign instances into a set of finite categories. But the difference between an ordinal regression task and a multi-class classification task is that in the ordinal regression, these finite categories are ordered. For example, we have a dataset of students' essays that were marked by teachers using A, B, C, D, and E grades. So we have 5 categories for grading, which we should assign each essay to one of them. But these categories are ordered, which A is the best one, then B is the second best, and so forth. Imagine that we train 2 neural network models which can mark essays automatically for us. For example, we have an essay which its real grade should be B. The left neural network model predicted a grade A, and the second one predicted a grade E. In terms of classification's point of view, both models failed to give us the correct answer. But we prefer the answer of the left model than the right one, since the left model gave us a closer grade to the real one, which B is closer to A than to E. So the goal is to train our neural network model in a way that it not only learns how to assign each instance to its category correctly, but also learns the existing order between the categories. By learning the existing order between the categories, the neural network model will give us at least a close prediction to the real one, in a case that it cannot predict the correct label. So to wrap it up, the ordinal regression is different from the multi-class classification since the classes are ordered. Also, the ordinal regression task is different from a regression task since in the ordinal regression, the output is discrete and finite. You now know what is an ordinal regression task and how it differs from multi-class classification and regression tasks. Now let's see how we can design a neural network model for ordinal regression tasks. In classification tasks, for the output classes, we usually put 1 for the correct answer and 0 for the others, which we call it a one-hot encoding representation. But in the ordinal regression task, we put 1 for all the categories that are lower than the correct category and 0 for those that are higher. For example, in the original data, the grade of the first essay is C. So we have 1 in the C column, but 0 for the other columns. We will change labels according to the bottom table, which all the grades that are lower than C will be 1 and the others will be 0. When we train a neural network model based on the modified labeling approach, the model can learn the existing ordering between the categories. For the prediction part, we always consider the highest rank category that contains 1. That for the first essay, it should be C. Same as the multi-class classification task, the number of neurons in the last layer is equal to the number of the categories. But instead of using a softmax, we use a sigmoid for the activation function of the last layer. This approach was proposed by Cheng and his co-authors in the following article. I hope you guys enjoyed this video. If you have any questions, don't forget to ask them in the comment section. And please like the video if you find it useful. I wish you guys all the best.